I welcome you all in this session. As you are aware, in previous session we discussed how to test a given hypothesis. We have seen a couple of steps, and today's session will revise those steps and then we will move further. So, in hypothesis testing there are 6 steps. The first one is you need to frame null hypothesis and alternative hypothesis. So, this is the first step, right. Then choose significance level and sample size. So, whether you want to test your hypothesis at let us say 90% significance level or 95 or 99, and appropriate sample size should be selected in step number 2, right. This is what we have discussed in previous class, the meaning of 5% significance level. So, if you want to test a hypothesis at 90% significance level, then in these two tails you will have 2.5% areas, right, and the remaining is 95. Or if you want this to be 90%, then this would be 5 and this would be 5, right. So, generally it is suggested that you should test any hypothesis at 99, 95 or 90% significance level. So, the higher the significance level, there is a possibility that you are rejecting a null hypothesis which is true. So, this is what we have seen in previous class as well. When you test a hypothesis at 99% significance level, you are not rejecting a null hypothesis, but at 50% significance level or when alpha is let us say 50%, then you are rejecting a null hypothesis, because this is the sample mean which is in rejection region, right. Determine the appropriate test which is to be applied. If standard deviation of population is unknown and sample size is 30 or less than 30, you use t test, otherwise z test. Determine critical value that will divide the rejection and non-rejection regions. So, you will come to know which regions are rejection regions and which one is not rejection region, right. So, in 2 tail test you will have 2 rejection regions, in 1 tail test you will have 1 rejection region. This is what we have seen as well in previous session. So, let us say there is a manufacturer who is claiming that the mean life of the bulb is 1000 hours. Now, if you are a customer, then would you buy those bulbs for which life is less than 1000 hours? Okay. We'll come to this particular part of the hypothesis in next slide. So, let us look at, so either, so you frame over here a null hypothesis like this, that the mean life of the bulb is 1000 hours and the alternative hypothesis it is not 1000 hours, right. So, you will have these 2 rejection regions, right. So, this region is a region where sample mean false and we will not reject null hypothesis, right. Let us look at the same example. So, manufacturer is claiming that the mean life of the bulb is 1000 hours, and you being a customer, you would not like to have those bulbs for which life is less than 1000 hours. So, what you want to prove? You want to prove this one, that you will not reject or you will reject those bulbs for which life is less than 1000 hours. So, this is one tail test, and this is also known as left tail test or lower tail test, right, lower tail test, right. So, in one tail test there will always be one rejection region. One more example on one tail test, this is an upper tail test, right, or right tail test. So, null hypothesis is this, that the let us say in this example you are manager of a particular sales area and there are let us say 50 salesmen working under your supervision, right, and you have given them a petrol allowance of 100 rupees per day. So, you should be, being a manager, you should be worried about only those expenditures where which are more than 100 rupees. So, this is the case of upper tail test, right. So, this is your rejection region and this is acceptance region, this side is acceptance region. Okay. So, the next step is collect the data and compute the value of test statistic. So, what is test statistic? Whether it is z value or t value depending upon question, right. So, the next step is make the statistical decision and state the managerial conclusion. So, statistical decision means you should either reject null hypothesis or you do not reject. Managerial implication means or a managerial conclusion means you need to take certain action after taking a statistical decision. So, if you reject a null hypothesis, then you are supposed to take some action, otherwise the current situation will prevail. So, if the sample statistic falls in non rejection region, do not reject, if falls in rejection region, reject it, right. Let us look at couple of examples. So, this is an example wherein the question is like this: how many standard errors around the hypothesized value should we use to be 99.44% certain that we accept the hypothesis when it is true? How many standard error around the hypothesized value should we use to be this much percent certain that we will accept the hypothesis when it is true? So, for this you would be requiring Z table, and in Z table if you look at, in fact you can do it like this: 0.9944 divided by 2, right. So, some 0.47 something like that, right. Now, look at that area in this table. So, 0.47, right, it is somewhere here 0.47. So, exact value you need to look at, in fact this is 2.77. So, 2.77 is this. So, in fact this is actually nothing else. When you divide this value, it comes around 0.497 and so on, right. So, when you divide 0.9944 by 2, you will get 0.497, right, and the Z value is 2.77, right. Okay. So, the interval should be this much standard error about the hypothesized value, right. Let us look at one more question. Martha Inmam, a highway safety engineer, decides to test the load bearing capacity of a bridge that is 20 years old. So, she has to check load bearing capacity of a bridge, right. Considerable data are available from similar test on the same type of bridge. So, some data are already available. Which is appropriate, a one tailed or a two tailed test, if the minimum load bearing capacity of this bridge must be 10 tons. So, this lady who is safety engineer, she has to decide whether one tail test is appropriate or two tail test is appropriate, and what she has to do, if the minimum load capacity of this bridge must be this much tons. So, what are null and alternative hypotheses? So, what would you do it? Here this is a case where the bridge has to have certain minimum load bearing capacity, and that minimum value is 10, right. So, she has to check whether the bridge can sustain this much capacity or not, right. So, she will have null hypothesis like this, it is equal to 10 tons, and alternative hypothesis its mu is more than 10. So, the engineer would be interested in whether a bridge of this age could withstand minimum load for safety purposes or not. She therefore wants its capacity to be above certain minimum level. So, that is why, because she wants the capacity to be above certain minimum level, and what is that minimum level is 10 tons, right. So, alternative hypothesis is this, right. So, it would look like this type of distribution, right. So, this is your rejection region, right. Let us look at one more example. We want to test a claim whether the average number of TV sets in Indian homes is 3 or not, right. So, our null hypothesis is this: average number of TV sets in Indian homes equal to 3, and alternative hypothesis is not equal to 3. So, which test we will be using? It is a two-tail test. How to decide whether we have to use two-tail test or one-tail test? The sign of the alternative hypothesis would decide. For example, this is greater than type in alternative hypothesis. So, that is why you are using upper tail test. If let us say an alternative hypothesis is like this in some other example, okay, then this is a case of lower tail test or left tail test, right. And if this sign is not equal to type in alternative hypothesis, then you will be using two tail test. So, keep in mind, for less than or equal to type of sign in alternative hypothesis, you will be using one tail. If it is not equal to sign, then you would be using two tail test, right. So, this is a case of two tail test, right. So, this is the first step. You need to frame null hypothesis and alternative hypothesis. Second is specify the significance level. So, in this question alpha is 0.05, right, and 1 minus alpha is 95%, right. N is 100. So, our null hypothesis is that average number of TV sets in Indian homes is equal to 3. We do not know whether there are actually 3 TV sets or not. So, what we did, we just collected data from 100 homes and we counted number of TVs in these 100 homes, and then we took the average. So, the average was this 2.84, right. So, let us move on to step number 3, determine the appropriate technique or appropriate test to be used. So, in this case we would be using Z test. Why? Because sample size is more than 30 and we have been given standard deviation of population. Okay. The next step is determine critical value from Z table, right. Since alpha is is 5%. So, the table value would be, we have checked earlier as well, it is 1.96. Okay. So, this is your critical values minus 1.96 to plus 1.96. Then collect the data. So, we collected data from 100 homes and we found that average number of TV sets is this, right, 2.84. Of course, this was already available with us, the standard deviation of the population. So, Z statistic would be calculated and this value is minus 2. Okay. Now, what is the next step? We have to take a call whether we need to reject this hypothesis or we do not reject this hypothesis. This means null hypothesis. So, is this test static in this rejection region? You have to check this. So, this is your Z value 0, right. This is Z value plus 1.96 and minus 1.96 from table we have got it, right. Now, the calculated z value is minus 2. Now, is minus 2 falls in this region in plus minus 1.96? No, it is outside this region. So, it is somewhere here, right, just see this. This is minus 1.96, this is minus 2, which is in rejection region. So, we will reject the null hypothesis. So, the test statistics is in rejection region. So, we will reject null hypothesis, right. And after rejecting, what we conclude? We conclude that the average number of TV sets in Indian homes is not equal to 3. When I say it is not equal to 3, it means more than 3 or less than 3. So, in this case what it is? Is it more than 3 or less than 3? It is less than 3, because our sample mean is 2.84. So, we will say that we will reject the null hypothesis and we will say that the average number of TV sets in Indian homes is not equal to 3, but less than 3. Let us look at one more example. Let us say you have to build, you are supposed to, let us say, construct a stadium, and for construction of stadium you need some aluminum sheets. Okay. So, you have selected a vendor who is ready to supply you aluminum sheets. Now, since you have to construct a stadium, the weight of the aluminum sheets should not be too much, or the sheets should not be too thick, otherwise the structure will collapse because of weight of the aluminum sheets. On the other hand, the weight or the thickness of the aluminum sheet should not be too thin, otherwise the structure will, let us say, it will not be a robust structure, is not it. So, the thickness of the aluminum should be proper, and that aluminum thickness sheet, as I said, should not be too thick and too thin. So, you have selected a supplier who would be supplying you aluminum sheets, right. So, that supplier has claimed that the mean thickness of aluminum sheet is 0.04 mm or centimeter, whatever you want, right. So, the supplier is claiming that the mean thickness of aluminum sheet is 0.04 mm with standard deviation of 0.004, and you want to test the claim which is being made by the supplier. So, what you have done? You just select 100 aluminum sheets, and you just when you calculated its the mean thickness was 0.0408, right. What is the claim of supplier? 0.04 mm, and when you took a sample of 100 and you calculated mean thickness as 0.0408. So, first of all, in this case you have not been given alpha. So, no alpha in this case. So, how to solve a question like this? So, first of all, calculate z value. Z is x bar minus mu, this is sample mean minus population mean, population standard deviation and sample size. So, this is 2, right. Now, once you are done with calculation of 2, what you should do? This is your population mean. So, population mean plus minus z into this standard error. So, mu is this, right, 0.04 plus z is 2 into this. This is standard error of mean. So, this would be what? This is sigma by root n, right. So, this becomes 0.0004. Okay. When you multiply it by 2, and when you calculate range, this is the range. So, this is your hypothesized population mean, this is the lower limit and this is upper limit, right. So, 0.0392 to 0.0408. Now, after finding these limits, you need to check whether your sample mean is falling in this range or not. So, our sample mean is exactly on this upper limit, is not it. So, you will reject the null hypothesis, since it is not in between, right, it is just on upper limit. So, you will reject the null hypothesis, right. Okay. So, this is a question which we have solved without having alpha value. So, any question on hypothesis testing can be solved if you do not have even alpha value, right. Let us look at the same question, and what you can do here is, since you know the value of z, right. Now, when z is equal to 2, you can easily find out this area, is not it, from table, right. So, it would be approximately 95.5. So, in fact, if you wish you can do this calculation, otherwise it is not needed at all, right. Let us look at next question. Let us say the strength of an axle is 80,000 pounds per square inch. So, this is our hypothesized population mean, which we are measuring in terms of pounds per square inch, right. So, strength of axle is this, and the alternative hypothesis is that the strength of axle is not this much. So, this is a case of a two-tailed test, right. So, you have been given hypothesized mean, you have been given standard deviation of the population, sample size and sample mean, and significance level, alpha is also given, right. So, how to solve this question? The first thing is, you can easily do it, calculate z value and compare it with table value, which would be 1.96, is not it. For this alpha value, z value would be 1.96, and you would be calculating z as well, is not it. So, let us look at this. So, the z value which you are calculating is this, which is -1, right. Now, -1 is z value, which is here, and the table values are 1.96 plus and 1.96 minus and plus, right. So, this z value is in between critical values. In other words, the calculated value, calculated z value is in between table value, right, or critical values. So, we will this is in non rejection region. So, we will not reject the null hypothesis, right. Now, there is one more way in which you can calculate the same answer. Now, this we have rejected null hypothesis after looking at calculated z value and critical value, right. You can do one more thing. You know this standard error of mean, which is 400, right. So, population mean plus minus z value, right, z value, z table value, right, into standard error. Now, this will give you again some range, which is 79216 to 80784, is not it. Now, just check, is your sample mean lying in this region. Is sample mean falling in these within these limits? 79600, yes. So, we will not reject null hypothesis, right. So, we have seen a couple of ways of deciding whether you should reject or not reject null hypothesis, right. So, if alpha is given, just calculate z and compare it with table value. If not, then you can have just you will always be having population mean plus minus z table critical value into this, right, and check whether sample mean falls in this range or not. This is another way of doing it, right. Let us look at a question on one tail test. Let us say there is a patient in hospital and you are supposed to give him certain medicines, right. So, if you are giving a drug dose of 100 cc to the patient and if you give excess dose, then it is not harmful for the patient, but insufficient dose does not produce desired results. So, what kind of null and alternative hypothesis will you frame? We know that excess dose is not a harmful, but if it is insufficient dose, then that would not produce sufficient or that would not produce desired results, right. So, we have to ensure that the dose size should not be less than 100, right. So, this is your null hypothesis and this is your alternative hypothesis, NH null hypothesis, AH alternative hypothesis, right. So, simple thing, since this is a case of one tail test, right. So, this 50% area is this and this side is remaining 50% area. Significance level is 10%, right. So, we are interested in this critical value. So, look at in Z table where area is 0.40, right. Why 0.40? Because this is one tail test, right, and our significance level is 0.10. So, 0.5 minus 0.1, it is 0.40, right. So, let us look at Z table and area is 0.40. So, 0.40, it is approximately 0.40, right. So, 1.28. Okay. So, your calculated value is minus minus 0.88 and table value is minus 1.28. So, this is your calculated value which is here and this is your table value. So, is this calculated value in rejection region or non-rejection region? So, this is in non-rejection region. So, we will not reject null hypothesis, is not it. So, we do not reject null hypothesis. Okay. So, we do not reject null hypothesis, it means what? We do not require any action now, right, because we have not rejected null hypothesis. Okay. So, we are saying that the dose size is 100 cc, right, this is the conclusion. So, let me summarize what we have done in today's session. We have looked at all the 6 steps of hypothesis, right from framing of null hypothesis and alternative hypothesis to selection of alpha, then to decide whether Z test or T test is to be used, then you need to calculate Z value, then you need to take a decision whether the calculated Z value is within rejection region or not, and then take appropriate decision. We have looked at a couple of examples on how to decide whether a question has got a 2 tail test or 1 tail test. To decide this, you are supposed to read a question very carefully, because hint will be there in question itself. If and if this sign in alternative hypothesis, let us say not equal to type, then it would be a 2 tail test. Why we call it 2 tail test? Because there are 2 rejection regions, and when the sign in alternative hypothesis is less than type, it would be a lower tail test, and if it is greater than type, it would be an upper tail test. So, let me stop here. In next class we will have some more questions. Thank you.